Okay, here we have a presentation for 9.1 for all of those sophomores who missed this particular class because of MCAS. It's a very quick session. We should get through it very quickly, and it should be pretty easy to kind of get around and understand. But let's go through a couple examples. So it's 9.1 in your book, and it's called Inverse and Joint Variation with a little bit of review of direct variation. Excellent. Okay, well, what is inverse variation? Well, inverse variation is y equals k over x. Inverse meaning as one thing goes up, the other thing is going to go down. So here we go. There it is at the bottom. So if y is going up, then x will go down. If x is going up, then y will go down, and vice versa. So we're going to use this equation. It's exactly the same as xy equals k, but we tend to always write it y equals k over x. It's going to help you remember it because inverse variation is going to have the x and the y not be in line with each other. So y will be sort of in the numerator and x will be in the denominator. K is never going to move. K is involved every single time. It is called a constant of variance, and k will be some number every time. So we will solve for that number first, but then it will continue to be that number through the problem that you deal with. It's never going to be 0, so it will always be there. All right, sometimes it might be 1, it could be 5, it could be negative 1/4, it could be anything like that, but it will be some sort of number. Okay, so when we think about something being inverse, I want you to think about as one thing goes up, another thing goes down, or vice versa. So something like the more you brush your teeth, the less cavities you have, because brushing teeth is going up, but cavities are going down. So something to think about. Another way to put that with numbers is, for instance, if you have this equation where we know that xy equals 40 or y equals 40 over x, what would happen if we change the values of x? Okay, so let's say we make x 5. Well, 40 divided by 5 is 8. Sorry, put these all in. So 40 divided by 5 is 8. And that's great, but what happens if we change x to 10? Well, 40 divided by 10 is now 4. So our x value, which has gone from 5 to 10, and our y value has gone from 8 to 4. Just to make that even more clear, let's say we change it x to 20. So now we have 40 divided by 20. Well, 40 divided by 20, cross out your zeros, and you just get 4 divided by 2. Well, that's 2. All right, and the last one, y equals 40 divided by 40. Well, 40 divided by 40 is 1. So take a look at these x values. These x values are going up from 5 to 10 to 20 to 40, while our y values are going down from 8 to 4 to 2 to 1. So as x goes up, y is going down. They're not going down necessarily by the same amount or up by the same amount. That's not what it's about, because k kind of tells you how the two are related. So how x is going up when y is going down. Okay. All right. So you're going to see this most often in problems like this. So the first thing I want you to do is to just not even think about this second line. Okay? Pretend that second line doesn't exist, because these problems are really two problems in one. The first problem says, let's write an equation that relates x to y when x and y vary inversely and y is 4 and x is 6. So what you're going to do is you're going to start with the generic formula, y equals k over x. Okay. We're going to write that general equation out. Then we're going to fill in our values of x and y, and we're going to solve for k. All right, so let's do that. Okay. Well, we take our general formula, y, oops, got to use a pen, that will make it a little bit nicer, y equals k over x, and we're going to fill in those x and y values. So again, we're talking about y equals 4 and x equals 6, not the x equals 12. All right, so y equals 4 and x equals 6. Okay, so we only have one variable left, and that's the one we're solving for. So let's solve for it. Multiply both sides by 6, and we'll know what k is equal to. So we get 24 equals k. Now that's not an equation. So and that's really what we were asked for. We were asked for an equation. Oops, sorry. I am underlining the wrong spot. An equation that relates x to y. And so that equation is this guy, is our y equals k over x, except, so this one, except we're going to fill in what k is, because k is that constant of variance, so we're actually going to fill it in. So y equals 24 over x. So now we have answered their first question. Okay, that first question to write an equation that relates x to y. Okay, it's sort of like a two-part problem. So we've answered the first part. Okay, now we go on to the second part. The second part says, okay, once you've got the equation, once we've got this guy, now let's use that to find y when we change our x value. All right, so we're going to change the x value to 12. So that means you're going to take that x value and you're going to fill it in and you're going to solve for y. So 24 divided by 12 is 2. So using that constant of variance that related this particular x to this particular y, well, we got y equals 24 over x. And then using that, when we changed our x value, we could see what our y value would become. So in that case, we have this y value of 2. So if you were thinking about these as something you could graph, we'd be making an x and y chart where our first values were 6 and 4, so 6 comma 4, and the next one was 12 comma 2. And so again, you can see how they're inverse. You've gone from 6 to 12, so we've gone up on this side, and we went from 4 to 2, so we've gone down on this side. So an inverse relationship. Wonderful. All right. You don't have to write the x and y chart. That's not required of you. You are just going to be asked to find the two circled things here. The y equals 24 over x, that's that equation that you've created, and then to find the y value when we change the x. So in our case, y equals 2. Perfect. All right. On to the next idea. Oh, it's going to scooch through just a couple things, but it's exactly the same as we've just gone through, so I'm just going to run through it a little bit quickly. There we go. All right. Oh, skip that. It's not your homework. Okay. So let's review direct variation. Now, direct means everything's going to be in a line. So y equals kx. And this means if y goes up, then x is going to go up. K has not changed. It's still your constant of variance. But if y goes up, x goes up. If x goes down, y goes down. They now go out. They go in the same direction together. That's why it's direct. They're in the same direction. There's also joint. And joint variation is almost the same thing. It's y equals kxz. So we've added one more variable. So when we say joint, what we're saying is y is related to both x and z directly. So as y goes up, x and z go up, or as x and z go down, y goes down. They'll go down in the same way. Okay? All right. So two values are now changing in relation to one. So these are sort of refreshing you from years past. So if you want to think about direct variation, you might think, the more you study, the better you do on a test. Or for joint, maybe the more you work on your endurance and the more times you spend practicing shooting in your lacrosse games, then the better chance you have of winning a game. Something like that. So two things, raising endurance and raising your level of practicing, in turn raises your ability to win games. So that's joint variation. All right. So sometimes you're going to be classifying some information. So I'm going to give us three little options here to look at. Remember that when you are looking for whether it's direct, inverse, or neither, that you want to rearrange it so it looks like what you expect. So, and for instance, we're not used to seeing it y over 5 equals x. So I would rearrange this formula so that I move the 5 to the other side. So it might look something like this. And then you can see the x and y are in the same line with each other, and everything's being multiplied. So this is an example of direct variation, because if I was to increase my y value, my x value would also increase. And that's something you might want to try too. You can always go, all right, well, I've got a constant of variance. What happens when I put in x is 2? All right, well, I get out y is 10. Well, let me increase my x value. Let's say I put out x is 5. So I've increased the x value. Well, 5 times 5 is 25. So y has gone from 10 to 25. So again, it has also increased. That's direct variation. No variation that we're going to talk about has any addition or subtraction in it. So for our next one, as soon as you see that addition sign, it's a neither. If you see a subtraction sign, same thing. You could have a negative sign, right? We could have a negative k value, but you can't have, k, a number minus something or a number plus something. That's not going to happen. For this last one, if you remember, that's one form of the inverse variation. If you don't, you can certainly rearrange it. But again, you can throw in numbers and give it a try. So let's say x is 1. Well, what does y have to be to have it equal to 4? Well, y has to be 4. So we've got 1 and 4. So now let's say I make x 2. So I've increased x. Well, now y has to be 2. So the 2 times 2 can be 4. So y has gone from being 4 to 2, while x went from 1 to 2. So x has increased and y has decreased. That is an inverse relationship. So again, you could rearrange it so it looks like this. So x and y are not in line with each other. And it is an inverse relationship. And I know on your screen it says indirect, but it really should say inverse. It's a problem that I have. I always want to say the opposite of direct, which would be indirect, but it really is direct and inverse. So please use the word inverse. You can also see it in table form. And all I'd want you to do for something like that is to take a look at your x and y values. So if we read this table, we have x values going up, 1, 4, 9, 16, 25, 36. Those are increasing. And our y values are also increasing, 1, 2, 3, 4, 5. So they're going up as well. So if they're both going up, then it's direct because they're going in the same direction. Okay. If you have one like this, take a look at this table. This table is not in order. We don't have an order to the x's or the y's. That's a problem. So you have to rearrange it. If you rearrange it and it still doesn't have order, then there is no variation here. Not one that we can classify as direct or inverse anyway. So you would have to say neither. But we could rearrange this one. And remember, these are points. They're tied together. You can't rearrange the x's and the y's any way you wish. Like, if I want to organize for the y's, I might put 0, 10 first. But it's 0, 10. That is a point. We can't separate the 0 and the 10 from each other. Okay, but let's rearrange for the x's. So if we do that, again, my 0, 10 has gone first. Then I've got 5 plus the next one of my x values. Or you could have done it by y's, either way. And if we look at this, it looks, as we go down our x's, we've got 0, 5, 10, 15, 20, 30. So we're increasing. And our y's are going 10, 9, 8, 7. So we're decreasing. So if one is going up while the other is going down, this is inverse. Please use inverse. I know it's going to say indirect again, but it is inverse. Inverse. Excellent. Okay. The very last thing you could see from this section, besides word problems, we will do a word problem as well. But that's to write a general equation. And these are general. These are with all variables, no letters, no numbers, all letters. So the first one we know how to do. That one's pretty straightforward. You've got, if y varies directly with x, well, that means always these will all have a k, but if it's going to vary directly, then we're saying y equals kx because they have to be in a line, right? They have to be all in the numerator to vary directly. Well, if it varies inversely, so y varies inversely with p, and notice it says y varies or x varies or like that, so that letter is what comes first. So y varies inversely. Now inverse means drop it underneath. So it varies inversely with p. P has become our x per se for this one. Jointly. Jointly means they're all in a line again. Y equals k. K is always involved. Q times r. Remember, jointly is just directly more than once. That's all it means. All right, this one says z varies inversely with w. K is involved, but it's inverse, so z and w are on different lines. Good. This second to last one, z varies jointly with x cubed. Oops, I forgot my k value. So k, x cubed, and m. So m is also in there. So again, all in one line because jointly is just directly, but with extra. And now the hardest one, this one is y varies jointly with d and z. So just do that part first. Okay, so y equals k d squared z, because that's jointly. Then go on to where it says inversely with g. All right, that means g's got to be not in line with it. So like that. So just take them in pieces. Y equals k, because you always have a constant of variance, and that constant of variance is always in the numerator. Anything that is joint or direct is in the numerator with the k, and anything that is inverse is in the denominator. Great. So you can try these. There are some excellent examples in your book in section 9.1. Great. Okay. So I'm going to run through this super fast. All right. Here we go. So here's how we can apply this to the real world. We might be asked to try and look at these kind of ratios together. So we have, in this case, the force needed to loosen a bolt varies inversely. And I want you to underline things like that. It varies inversely, and that's F that varies inversely, with the length of the handle L. Write an equation relating F and L given that 250 pounds of force must be exerted to loosen a bolt when using a wrench with a 6-inch handle. How much force must be used when the wrench handle is 24 inches long? So remember, these are two separate questions. You have the question that's being asked first. Let's do this in green, let's say. That's the question asked first. All right. And then you have another question asked after that. That says, that's the second part in pink. So we want to handle one question at a time. All right. So this guy varies inversely. So as soon as you see that, we know we're writing a y equals k over x1. They gave us different variables, but it's basically that. So in this case, it says f varies inversely. So it's going to be f equals, and inversely means k on top and some variable on the bottom, and it varies inversely with L. So we're going to have L on the bottom. Okay. Then it says, given that 250 pounds of force, remember that F is force, because it tells you up here, it's force. Too much force. There we go. So we want to plug in 250 for our force is equal to K, again, over our L. And it says that force must be exerted to loosen a bolt when the wrench has a 6-inch handle. So remember, L is the length of the handle, so L is 6. All right, that means we are going to multiply both sides by 6 to get what K is equal to. So we should have 1500 equals K. Now we still haven't quite answered the problem, because the problem says write an equation relating F and L. So our equation relating F and L starts with this guy, but it has to continue by filling in K. So F equals 1500 over L. That is your equation. Perfect. All right, so we have completely answered the part in green. So now we move on to the part in pink. That's where we've made some kind of a change. How much force must be used when the wrench handle is 24 inches long? All right, well now the handle has changed lengths. So let's do that one. And then we do that one in red. So we use the same equation, F equals 1500, but now our length has changed to 24. So our length has increased, and remember this is an inverse relationship between F and L. So because the length has gone up, we expect the force to go down. So if your answer doesn't have your force going down, something went wrong, and we kind of have to check that out. So you want to do 1500 divided by 24. And again, you are perfectly welcome to use your calculator. This is a real world example, so we kind of want to see it as a number that we can relate to. 1500 24ths, we don't know what that is so much. But if we actually do the division and get 62.5, that makes sense to us, that f is equal to 62.5. When you answer this problem, though, I want you to answer it now because it's the answer to a word problem, so I want some English in your answer. And it says how much force must be used. So you're going to say you must use 62.5 and use the correct units, and it looks like it's pounds of force. So pounds of force must be used when the handle is 24 inches long. Okay, I really want a complete sentence for that. So when you give that answer, you sort of give the whole thing. Excellent. This is exactly the type of problem that you might see come up on a test or a quiz. There is homework related to this, so please check on Edline for the rest of that homework. Otherwise, excellent. If you have any questions, please feel free to email me or see me after school on Monday. Thanks so much. Have a great weekend, guys.